and some cold water, to which I've added blue food coloring so that it's blue. And what I'm going to do is I'm going to pour them into this 2-liter beaker that I've divided with a piece of foam core. Let me do that first. So now remember, the hot water is red and the cold water is blue. And let's see what happens when I pull this piece of foam core out. If you look really closely, what you'll see is that the red layer is on top and the blue layer is on the bottom. And it's actually reasonably well layered. Now that it's sort of settled down, maybe it would help to have a piece of white board behind it. But it's pretty highly stratified. Now, what's floating on top? The hot water. And what's on the bottom is the cold water. And in general, if you have a liquid, the hot liquid is going to be less dense than the cold liquid. How can we understand this on the atomic molecular level? That something that's hot has a lower density, because that's how it's dividing itself, is that the hot water has a lower density than the cold water. And the answer is, think about this. If you're at a party that's a cocktail party and everyone's just standing around and talking, you can have a lot of people in the room and they don't take up much space. But if you have a dance party where people are, gyrating and bumping into each other and knocking each other down, then they're going to take up a lot more space. They have more energy, they're going to take up more space. So the idea is that when you have something with a lot of energy, it occupies a greater volume, all other things being equal. So the same amount of compound, the one that has the greater average kinetic energy is going to take up more space. We see this also in gases, that hot gases have a lower density than cold gases. Well, in this case, what we're observing is that hot water has a lower density than cold water, and so this is why hot water floats on cold water. Now, where this might impact your life is that this has been sitting around for a while now, and it's still pretty clearly the case that the hot water is on top of the cold water. When you draw your bath, if you draw first cold water and then hot water, it's going to be somewhat stratified. And so even though the water on average is some temperature that's very comfortable, you might find that you still get burned because the hot water is sitting in a layer on top and the cold layer is sitting on the bottom. And so if you want to avoid getting burned, what you need to do is turn on both taps and run the water out at a temperature that you want, so that there's much more intimate mixing, as opposed to running just hot water and then just cold water, or vice versa. So again, the points are, they decide where they're going to go based on density. So the hot water is floating on top and the cold water is on the bottom, because the hot water has a lower density than the cold water.